If you were ever like me, as an aspiring young scientist, you probably went to the amusement park and were just like completely like mind blown at the roller coasters and how they worked. So I thought it'd be kind of fun to go back to that and visit the gravitron. And I thought it'd be fun to figure out the minimum velocity needed to keep the rider sticking to the wall. Now, we already have some other numbers here that we're going to use to find. We have the radius, the mass, the gravitational field strength, and the coefficient of static friction. But first, I think it's always wise to draw a free body diagram. We're going to have three forces on this. We have the gravitational force, we have the friction force, which is going to be static because we want our rider to be stationary, not in motion. And we're also going to have the normal force pushing perpendicular to the gravitational force because the gravitron is pushing on the rider. So it's always a good idea, I like to do, is expand Newton's laws in both directions. So I'm going to start out with y. Now, because I want the rider to be stationary, I want no acceleration in the y direction. So I'm just going to write out the friction force minus the gravitational force equals m, and then acceleration in the y direction. And that's going to equal 0. So we're going to set the friction force equal to the gravitational force. And because the gravitational force is equal to m times g, the frictional force will equal the same thing. Now, in the other direction, in the x direction, or in this case, the centripetal force, which is going to be the normal force, we're going to do the centripetal force times mass equals mass times the centripetal acceleration. Now that's going to be Fn equals mass times centripetal acceleration. And here we have centripetal acceleration equals velocity squared over r, and that times the mass equals Fn. Now, we don't have any numbers for Fn, so we're going to have to use another formula that involves the friction force and the coefficient of static friction. Now, just rearranging this, we get the friction force over the coefficient of static friction equals mass times the velocity squared over r. Now, we have the friction force, which equals mg. So we can write that here, mg over the coefficient of static friction equals mv squared over r. We can cross out m, and we're left with g over the coefficient of static friction equals v squared over r. Do some simple algebra. You're going to get g times r over the coefficient of static friction. Take the square root of that. It's going to give you your velocity. Now, just do some numbers. You're going to do 9.8 times 7 over 0.2. Take the square root of that. And I'm just going to write this over here. That's going to be equal to 18.5 meters per second.